We're now going to look at Chapter 7-4, Properties of Similar Triangles, and I'm going to split this up into two parts because it can get quite interesting. First, we're going to look at the triangle proportionality theorem and its converse. So let's go ahead and take a look at that. Triangle proportionality, well, that just, when you read that title, you're thinking, okay, I'm going to deal with proportions, and that's exactly what we're doing. So we're going to take a line, cut it through the triangle, make it parallel to one of its sides, and that creates a proportion. So this theorem states if a line parallel to a side, any side, is cutting through or intersects the triangle, then it divides those two sides proportionally. And that's what we have here is our if statement. If we have these parallel, and then we have this. This right here, this segment right here, AE is over EB, is proportional to this segment right here, AF to FC. Now, we're not going to require you to do the proof, but I want you to get a feel for where it gets started. When we have parallel lines, one of the things I taught you early on in the course is that think transversals. Well, we have two transversals. We also have corresponding angles. That gives us congruent angles right here. And the same for this transversal. We have congruent angles here. So given two lines in a transversal that are parallel, the lines are parallel, we have congruent angles. Then we can easily prove angle-angle similarity using this triangle right here versus the big one. Then we would use the segment addition postulate to break these apart, play with them a little bit using some arithmetic, and we can prove proportionality that way. The proof is actually kind of complex for this level of a course. So we're not going to do that to y'all. But I do want you to know this theorem. In short, let's just call this A, B, C, D. And with given these parallel lines, or parallel line to one side, we can write our proportion just like this. A over B is equal to C over D. There's more than one way to write this, though. I'm going to show you this next slide. And there's 6 quick ones that you can do, and then we have some inverse ones that we can also play with. So here's the one that I just wrote. A over B is equal to C over D. There's more than one way to do this. Now, you don't have to memorize all these. You can if you want, but there's no reason to. The key to understanding this problem is to understand how to compare. Make sure you're comparing the right thing to the right thing. So here we started off with A, and we compared it to B. Well, guess what we're going to do on the other side? We're going to start off right here and compare it to C. So we have A over B is equal to C over D. But it doesn't have to start off that way. We can do something else. Let's just say we want to start off with B. And I want to compare it to D. Well, guess what I got to do up here? I got to do the same thing for the other part of the triangle. I got to compare A to C. So I'd have B over D is equal to A over C. And that's this guy right here, only written backwards the way I said it. And it can continue on. Now, I got to keep my parallel line in there. I can compare A and J. So I can write A over J right here. But I got to do the same thing for the other side. I got to compare C to K. There are bad ways to do this. For instance, if I started off with A and I compared it to B, I don't want to take D and compare it to K. It's not going to work out too well. It's got to be the same kind of direction, same kind of feel, same kind of, basically, I'm going to say it again, yes, apples to apples and oranges to oranges. Study this. Look for the patterns, but you do not have to memorize. Know the patterns, though. Let's take a look at an example. All right, this is number 8 on page 485. And we need to find KL. Well, let's see if we have the requirements of the theorem. Here's my line that cuts through the triangle. It is parallel to one side. Looks good. So it looks like we fulfilled the proportionality theorem. So what we're going to do is we're going to compare two things over here. And I don't know what this is, so I'm going to call it X. So there's many different ways I can write this. I could do 6 over 4. Is equal to, you bet, I started from here comparing to that, so I better go this way, 8 over x. Use my cross products, I get 6x is equal to 32. And I'm going to divide by 6 on both parts. So 6 goes into 35 times. Gives me 2 left over. So 5 and 2, 6. Which is equal to 5 and 1/3. So this length right here is 5 and 1/3. That is a 3. Promise, promise. I could have set it up differently. I could have done 4 over x. I went from here to here, but guess what I got to do? I got to go from here to here. Don't reverse it. That would be a no-no. And I would have done 6 over 8. And cross products, I would get the exact same thing. 32 is equal to 6x. I could have made it more complex, and we're going to have to learn how to do that. Like, for instance, this whole side right here is 10. And this is nothing more than 8 plus x. Now, we wouldn't do it for this kind of problem. I just want to show you where we can go with it. I can do 6 over 10 is equal to 8 over 8 plus x. A little bit too much work, but you will have problems that will involve that kind of thing. All right, so let's go ahead and move on to its converse. The converse is just basically exactly what you're used to when you deal with converse theorems. We're working backwards. If we have a proportional situation already, here's my given. If we have this, and we have a line cutting through it forming these ratios, then we have parallel lines. It's kind of intuitive. If we have, again, A, B, C, and D, if A over B is equal to C over D, we then have to have parallel lines. There's no other way around it. So then we have parallel lines. Let's take a look at an example. So here's an example that shows the converse, and I pulled this off of a worksheet or somewhere. And we want to prove that this line right here is parallel to this line here. Verify and basically prove. But we're going to use that using proportions. Now we're given all 4 parts, which is a good thing because it'd be kind of hard to do without all 4 parts. And I could set up my proportion any which way. I could start from here to here. And if I do that, I better compare the same side in the same manner. So let's go ahead and do 10 over 15 is equal to 8 over 12. And these fractions simplify, well, 5 goes into that 2 times, so it's 2/3. And guess what? 4 breaks that down into 2/3 as well. So no surprises there. This works out. I verified. I am done. This is what you've got to prove. So I can put my little parallel lines right here, and I've verified. I could have done this different ways. I could have done it like this. I could have started with 8 and compared it to 10. More than one way. We showed you 6 good ways on the previous slides, and that means I better start with 12 over 15. Well, this breaks down, well, let's see, no, 2 goes in that 4 times, so 4/5. I better get a 4/5 over here, or I'm going to be very sad. Yep, 3 goes into that, so I get 4/5 as well. And there we go. I verified a different way. And there's more than one way to do it. Try the different ways of verifying this. Alrighty, so that's it. I'm going to give you part 2 here shortly. And this is stuff you got to study and practice.